Chapter 11, Section 6, Surface Area and Volume of Spheres. A sphere is the set of all points in space that are equidistant from a given point called the center of the sphere. The radius is the segment that has one endpoint at the center and the other is on the sphere, so anywhere on the sphere. The diameter is the segment that passes through the center and both endpoints are on the sphere. So just like in a circle, but now it's three-dimensional. You can find the surface area and the volume of a sphere when you know its radius. Just a few things to go over. When a plane and a sphere intersect in more than one point, the intersection is a circle. So when we talked about cross sections, the cross section here would be a circle. So whenever a plane intersects a sphere. If the center of the circle is also the center of the sphere, it's called the great circle. So pretty much the biggest circle that you could get. The circumference of a great circle is the circumference of the sphere. A great circle divides a sphere into two hemispheres, so two half spheres. So here we're using our formulas for surface area and volume of a sphere. So surface area, the formula is going to be 4 pi r squared. There is no lateral surface area here because there are no lateral faces. So we're just doing surface area. The diameter is 10, which means that the radius is 5 meters. So we plug in 5 for the radius, use the formula, and get 100 meters squared because it's surface area. For the volume, we have this formula. Now it's radius cubed. The radius in this case is 6 meters. So 6 cubed times pi times 4/3 gives us 288 pi meters cubed. In this example, we see the volume of a sphere is 5,000 meters cubed. This question wants to know its surface area to the nearest square meter. Well, if the volume is 5,000 cubic meters, that has to equal 4/3 pi r cubed. We want to find out what the radius is so that we can take that and plug it into the surface area formula. So in order to get rid of the 4/3, we're going to multiply both sides by its reciprocal. This way it'll cancel out. This will give us 3750 equals pi r cubed. We're going to divide both sides by pi. That'll cancel this out. Now, you're going to do this all in your calculator, but the 3,750 divided by pi, in order to get r by itself, we need to take the cubic root. So in your calculator, you're going to type in the cubic root. So press math, go down to the cubic root of 3,750 divided by pi, and it asked us to round the surface area to the nearest square meter. So that means you're going to get the radius as around 10.607844. Don't round anything yet. You only want to round at the end. So in your calculator, you're going to do that number squared, since it's radius squared, times pi times 4. And you'll see that you get 1,414 and some decimals, but it asks us to round to the nearest square meter. So that's going to give us 1,414 square meters. So don't round until the end. I mean, you're safe with at least like 3 or 4 decimal places here. But just to make sure your answer is as accurate as possible, try not to round until the very end. Chapter 11, Section 7, Areas and Volumes of Similar Solids. Similar solids have the same shape and all of their corresponding dimensions are in proportion. The ratio of corresponding linear dimensions of two similar solids is the scale factor, which we've seen in similar figures, now it's similar solids. Any two cubes are similar as well as any two spheres, so it doesn't matter what their lengths are, because in a cube all of the side lengths are the same, and because in a sphere you're really just worrying about the radius in order to find any sort of dimensions or the diameter. any two cubes will be similar and any two spheres will be similar. Here it's asking, are the two rectangular prisms similar? And if so, what is the scale factor from the first figure to the second? So it has to be written in that order. So here we can see we have 3 over 6. It has to be corresponding parts. That gives you 2/4, and that reduces down to this. So 3 over 6, 3 over 6, 2 over 4. They're all the same proportion, which means that the prisms are similar because the corresponding linear dimensions are proportional. The scale factor is 1/2 because it's trying to go from the first figure, which was 3, to the second figure, which is 6. So 3 over 6, 2 over 4 all reduces down to 1/2. In letter B, we have 2 over 3, 3 over 6, and 2 over 3. 2 over 3 and 2 over 3 is not equal to 3 over 6, so the prisms are not similar because the corresponding linear dimensions are not proportional. Here we're being asked, are the two cylinders similar, and if so, what is the scale factor of the first figure to the second figure? Well, we would have to do radius over radius equals height over height. This reduces down to 6 over 5 as well, which means that the scale factor is going to be 6 over 5, or 1 1/5. If the scale factor of two similar solids is A to B, then the ratio of their corresponding areas is A squared to B squared. We saw this when we did similar figures. Now it applies for similar solids as well. And the ratio of their volumes is A cubed to B cubed. So here we're being asked, what is the scale factor of two similar prisms with surface areas of 144 meters squared to 324 meters squared? Well, this is talking about surface areas, which means it's A squared to B squared. So to find out the scale factor, we're going to take the square root of both, and we're going to get 12 meters to 18 meters. Are any two square prisms similar? Well, that's going to mean that, let's say we have one square prism here, and another red square prism there. Well, a square prism, this could be 3 inches, let's say, but the height could be 7. This could be 6 inches, and the height could be 3. So they have to have bases, which will be in proportion because all squares are going to be proportional, so all squares will be similar. But because the heights may not be in proportion, so we have 3 over 6 going from here to here equals 3 over 6, but that does not equal 7 over 3. So no, any two square prisms will not be similar, but any two cubes will be, because then they'll have the same height.